Pulleys. Pulleys are fun and easy, especially due to the fact that in this particular class we will consider frictionless pulley. We might consider their mass. That shouldn't be too much harder. But the nice thing of a pulley is this. Let's say the pulley is fixed on its axle and you're putting on the string with a particular force F. Then you know right away that on the other side of the pulley or on the other side of the string there's going to be the exact same force in the opposite direction. So if you're putting with a particular force down, let's say you put a bucket with a particular mass, you know that on the other side of the string, so you just have to follow the string, here is going to be the exact same force magnitude as the one you just applied. The direction might be different. That is, if you're putting down with force F and the other side is down, then the direction will be in the same as this one, and the magnitude will be the same. If the pulley is mounted on the table and you're putting down with the force F, then even though that force or that string is now horizontal, you know that on the other side it's still F. So that's nice, that's very nice. If you're dealing with a massive pulley, then all you have to do is add another force here, W, which acts at its center. Now, if you have several pulleys, let's say a pulley here attached to the ceiling, I'm putting with a particular force. I know that as I follow the string, I'm going to have the same force on this side of the string, and let's say I have another pulley right here, which is mounted also on the ceiling. What is the force right here? Well, I know that the force applied here is the same as the force applied here. And I know from Newton's third law that if I have a force coming down at the junction is the same as the force coming up applied to this time this pulley. And then I go back to the property of a pulley. If I pull up with the force F, I know that there is the exact same force on the other side with the same magnitude. Therefore, this force is F. So it's very nice, just follow the string. If you're putting with a particular force on one side of the pulley, then follow the string, that force is always the same. And you can have 1, 2, 3, n pulleys, doesn't matter. So an interesting application would be an object with a pulley mounted on it. So this pulley is attached to this block. I am putting with a particular force F on the string attached to this pulley, which is in turn attached to another pulley and connected back to my object. And let's say this one is connected to a ball. So I'm interested in the external force acting on this object. I know there's two connecting points, so there must be a force here, let's call it T, and a force here, let's call it R. And at this time I have no idea what T is and I have no idea what R is. And actually, since I'm at it, let me blow it up. So T and R, I have two contacts here, here. Therefore, due to this mounting point is acting with a force on my object S, and this string is also acting with an external force R on my system S, and both are going towards the left. So I need to figure out what T is and what R is. Well, R is pretty easy to figure out. I just need to follow the string. If I'm putting with the force F on this side, if I follow my string, I know that the same force is acting here. Then due to Newton's third law, I know that this is also the same force acting on this pulley. And I keep following the string. this is also the same for F, which means that R is equal to F. So that was easy. Now, but what is T? Well, let's do a free body diagram on this pulley. I have a pulley, force F, another force we know is the same. If those two forces are the only force, my pulley should go towards the left. But it isn't, because it's stuck here with my system. So there must be another force pulling on towards the right. Let's call it P. So I know that P is equal to 2F in magnitude. But hey, we can reuse Newton's third law. The same way as we did here, F must be equal to R, P must be equal to T. Therefore, in magnitude, they are the same. Therefore, T is equal to 2F. So when I go back to my system S and I'm trying to figure out the external forces acting on it, I know I have a force of 2F and then another force of F. Therefore, overall, I have 3 Fs. So pulleys are nice, because in this particular case, I'm only using a force of, say, 1 Newton to pull that object S towards the left, but if I hook it up in this particular configuration, I can triple the amount of force that I can apply to this system. So that's very, very nice. That's what pulleys are for. Either minimize the magnitude or maximize it. In this particular case, maximize it.